Hello everyone, how you all doing today? Welcome to Math Direct. So today's video we are going to be talking about derivatives of logarithm. Derivative of logarithm can come in different ways. When you see logarithm in base 10, or if you see something like this, base 10 is equals to y, something like that. This is logarithm. This is what we learn in high school. And when you see a term ln x, this is also logarithm. Can come in different ways. When you see log in base 10 equals to y, this is logarithm as well. So these terms can be differentiated. You need to understand and know how to differentiate this problem. And when you understand how to differentiate logarithm, you can solve any problem. So when they give you a term, differentiate d over dx ln x. So when you see d over dx ln x, to differentiate this term, let's say y is equals to ln x. So dy over dx is equals to 1 over x. So this is the answer for differentiating ln x. So whenever you see ln x, that means it's 1 over x. And when you see differentiate d over dx ln ax, so a vanishes, this is also equals to 1 over x. So when you see this term, you know that this is what it is. When you see differentiate ln x, this is ln x is equals to 1 over x. And logarithm can come in different ways. When they give you a problem like d over dx logarithm base 10, let's say base 10 a, they give you this term, say differentiate this term. A lot of people will get confused where to start. The only way to solve this problem is to break it down further in order to solve the problem. So if you remember in high school, y is equals to ln 10a, and 10 raised to the power of y is equals to a. So you ln both sides. Ln 10 y is equals to ln a. So y comes over here, y ln 10 is equals to ln a. So now y is equals to ln a over ln 10. So this 10, remember, this is the base. So base is always constant. So we can now, this is the same as what we have here. This is the same. So now we have to we can differentiate this term now. Ln a over ln 10. So we have to say dy over dA is now d over dA ln a times 1 over ln 10. So if you differentiate ln a, is equals to 1 over a. So 1 over a times 1 over ln 10. So which is equals to 1 over a ln 10. So this is your answer. Differentiating, you went from logarithm to base 10 a, and we simplify it. We brought it down to a simple form in order to differentiate. So we differentiated that and we got this. So ln a equals ln 8 divided by ln 10 equals to y. So we can now differentiate this and keep the base is 10 constant. So this is base here as well. So when you see this kind of problem, this is how to tackle this problem. So now you understand how to differentiate ln x when it's in logarithm ln x, or log, which is logarithm in base 10, and you simplify it and you differentiate. So this is how to do it, and we will be solving a lot of problems, But before we move further, we need to record the logarithm terms. The logarithm terms, when you have ln xy, so this is xy, so this is ln x times y. This is equals to ln x plus ln y. And so when you have ln x over y, this is equals to ln x minus ln y. And when you have ln x minus 1, or let's say when you have here ln 1 over x, this is equals to ln x minus 1. So this is equals to that. So these are the terms you have to understand. And when you have e ln x, so this is equals to 0. These are the terms you need to understand on how to do. So this is exponential, differentiating exponential. Let's see, we have ex, exponential is equals to ex. So differentiate exponential is this. So we will be solving problems, regarding using all these terms we have learned, and we will be putting all our rules together. We'll be using the chain rule, we'll be using our product rule, our quotient rule. We need to understand all these things, and we need to understand on how to differentiate. If we see logarithm or see any terms like this, like ln or logarithm, I already shown you on how to do it, and we have to apply all our skills, all the stuff we have learned so far. We have to put them on one thing. Let's say if we have exponential, as I said before, this is exponential. So differentiating exponential is this, and differentiating exponential e minus 1 minus x is equals to e minus x. So it's the same. So this is what we have to learn, what we have to know in order to solve problems. But the next thing we have to do now, we have to solve a bunch of problems using logarithm. Okay, let's say for instance we have differentiate d over dx ex ln x. So we have a problem here like this, and we need to solve this problem. And look at this problem first. You know that this is products. So exponential e raised to the power of x times ln x. So if you look at this stuff, you understand that we have to put in our product rule here in order to tackle this kind of problem. So how can we tackle this problem? Let's say we have y is equals to ex ln x. So we need to tackle this problem. We differentiate exponential raised to the power x, keep ln x constant. We differentiate ln x and keep exponential constant. So dy over dx will be, so d over dx exponential x and keep ln x constant, plus differentiate that d over dx ln x and keep exponential x constant. So this is how you differentiate this. So let's differentiate. So we already talked about when we differentiate exponential x is equals to exponential x. So ex times ln x plus differentiate ln x is 1 over x. 1 over x ex. So this is your answer, but we have to simplify this in a nice term, like in a simple term. So we have to simplify this. So ex ln x plus ex over x. So if you look at this term, we can say divided by x. So 1 by x is x, so x ln x plus x is 1, so 1 plus times ex. Now we have common terms here, ex raised to the power x, x ln x plus 1 divided by x. So this, we already broken this answer in a simple form. So differentiating this is equals to that. So this is dy over dx. So this is a simple example, and we put all our rules, the rules we've learned. We use product rule to solve this problem. Let's say we have d over dt ln t over t. So looking at this problem, you understand that we have this is a quotient rule. So that's what goes to your mind first. This is a quotient rule. So quotient rule is division. So what's quotient rule? We have to differentiate the numerator and keep the denominator constant, minus differentiate the denominator and keep the numerator constant, divided by the denominator squared. So this is what we're going to do now. Let's say y is equals to ln t over t. So dy over dt is equals to differentiate the numerator, the one on top, d over dt ln t, put t constant, minus differentiate t, d over dt, t, and keep ln t constant divided by t squared. So differentiate ln t is equals to 1 over t times t, minus differentiate t is 1 times keep ln t constant divided by t squared. So let's break this down, simplify this in a simple terms. So t cancel t is 1. So this is equals to 1 minus ln t over t squared. So this is your answer. Yeah, this is your answer. This is how to solve it. You can break it down even further, but this is your answer. So dy over dt is equals to that. So this is how to tackle this problem. Just let me know in the comments if you understand how I solve or how I derive this answer. We apply quotient rule here, and this is our answer. D over d theta ln cos theta. Let's say, for instance, we have something like this. How can we differentiate this term? So looking at this term, you know that we are going to apply the chain rule here. So we say u is equals to cos theta, and we differentiate du over d theta. So remember, for trigonometry, to differentiate cos theta is minus sine, right? Minus sine theta. So your du over d theta is minus sine theta. So now you have y is equals to ln. So this was replaced, ln u. So we can say dy over du is equals to 1 over u. So we applied the chain rule here. So we looking for dy over d theta is equals to dy over du times du over d theta. So we already have our dy over d theta here, and we have our dy over du here, so we put them together. So 1 over u times minus sine theta. So that is, so u here is cos theta, so minus sine theta over cos theta. So your dy over d theta is equals to minus sine theta over cos theta. And if you remember your trigonometry, sine theta over cos theta is equals to tan theta. So this answer is equals to minus tan theta. So your dy over d theta is minus tan theta. So this is your answer. We started from here and we arrived here. So all this derivative of this is that. So you have learned how to apply the product rule, the quotient rule, and to apply the chain rule in order to solve a logarithm. One thing you should understand about the logarithm terms, we have a power factor. So power factor, when you have a term d over d x to x. So this is a power factor. Power factor, in order to differentiate this power factor, is 2x ln 2. So this is the derivative of this. So in order to prove this term, if you understand the first principle of derivative, when you have fx plus h minus fx divided by h, when you say fx differentiate this, so we can use this to prove this answer. In order to solve more problems like this, let's say we have d over dx 2x over x. We apply quotient rule here. So when we differentiate this term, the one on top, the numerator is already know that is this. So it's 2x ln 2 and keep x constant minus differentiate x is 1 and keep 2x constant divided by s squared, and this is 2x ln 2x minus 2x over x raised to the power 2. So we can say 2x, in order to simplify this answer, 2x ln 2x divided by x squared. So this is the answer to this problem. So make sure to subscribe to Math Direct, and I'll be solving a lot of problems in this channel, and support this channel by subscribing. And thank you so much for watching, and I'll see you guys later. Peace.